Hey YouTube, and welcome back. In part one of this machine learning of things training session, we learned some basics about machine learning and how it can be used to build a model. We then built a model that can be used to predict if a patient has a heart disease or not. Now, in part two, we used the same knowledge, the knowledge we've gained, to build an ML model for our problem statement. Again, this was our problem statement where Francis has a dog and, we want to use machine learning to control the fans in his room, right? Now, in this video, we will discuss and run an exercise on how we can upload the model, use the model that we've created, right? So this was the model we created, right? We downloaded it in the last video, and you can see we have a dog fan model and a studio fan model, the joblib files, right? So we're going to see how we can deploy these models and how we can use them in the cloud. You will be provided with the circuit diagram and code for how to build a similar circuit. Like you could see, here is the circuit. You will also be provided with a link with the simulator like we've done in our previous videos. However, here is a similar design for what we would have in Francis's home, where you have the red fan for Parsons's room and the blue fan for the studio room. That's Francis' room. And the two temperature sensors for both rooms, ESP32 microcontroller, and two motion sensors to detect when there's motion in each of the rooms. There are also two MOSFETs here that help us control these fans, right? And you'll be provided with a backend server. You'll be provided with the code for the backend server and code for our event hub. Essentially, we would be going through a walkthrough on how you can host this model so that our circuit here can use the model, and when it detects a particular temperature within the room, it uses the model to predict if the fan should be on or off. It's a lot going on at the same time, and I know, right? But I really do hope you have enjoyed this machine learning for controls training sessions so far. Please feel free to subscribe and post your questions in the comment section. And now let's get into it. First of all, we will need to download our API code. So let's go ahead and download this. Okay, maybe let's start first by creating a server where we want to host our project. But let's go to our API code. So this is IoT MQTT machine learning code. Now the code will be provided for you. Let me widen this a little bit more. The code is going to be provided for you at the description of this video. So we're going to download the code from the V1 API server. And now I think the first thing that it says is we need Python 3, right? So one of the major requirements is we need Python 3 plus, right? So we need to install Visual Studio Code. You can walk through this installation instructions. It shows you a lot of things on how to set up right now. Install Python 3, but before that, we're gonna install Python 3 on our custom server, right? So if you're using a Linode server, setup process for using Linode server is here, right? So we're gonna use Linode server for this. So first is to create a Linode account, right? So let me create one. So I'm gonna download this, copy that rather, and I'm just gonna paste that there. Okay, so it's just linode.com anyway, so now I'm gonna sign in. Let me log in. If you don't have a Linode account, please create one. So if you look here, you'd see that I do have some servers already, right? So if you don't have one, please create one. You might be asked to put in your credit card, but even if you put it in, Linode does give you like $100 that you can use to create servers. I'm just gonna create a server, and I'm gonna create a Linode server, right? So it says we should create a Linux server. You could choose Ubuntu 22.04, right? So let's do Ubuntu. Let's choose this one. Select a region, all right? It's a little, New Jersey's a little bit closer to where I am. We need to select a plan. We want the shared plan. This is $5 a month, and it's okay. It's 1 CP. So I'm just gonna select this one, this 1 GB one. Now we want to create a name for it, right? IoT Masterclass ML. Fresh one. You don't really need to create tags if you want to. Now you need to set a password. So just gonna set a password. And now it says you can add an SSH key, right? So if you don't have an SSH key, you can add it, right? I already have an SSH key that I've added to this Linode account previously, so I can access it from my Mac. Now, basically, you can create an SSH key. So here, if you go through this, and now we've done our password, right? Now, adding an SSH key, to generate an SSH key, you can use this command right here. Just change your username and stuff, and you can generate your SSH key. Now, if you want to see some examples, you can go to this link, and you should be able to get some examples on that, right? Once you generate the SSH key, you would go to the location where you generated, and you would copy the contents of the .pub file, the public key file, and then you would come here and click add SSH, right? So when you click add SSH, you create a label for it. Could be anything. I just use UFO, which is your user, and then you put in the contents of that file. So just open the file in the text file and copy the contents and paste it there. Now, once you paste it there, that's fine. Now, if you don't create an SSH, if you didn't create an SSH key when you started this, right? You can go, I think somewhere at the top here, there is a place here, you go to your username and there's SSH keys and you can add it from there also. All right, so that's just by the way, right? Attach a VLAN? No, we do not want to attach a VLAN. We don't need backups. It's just gonna cost us more for now. It's just a test server. Private IP, not really necessary. So the name is IoT Masterclass ML1. And now I will create the Linode. Is it Linode or Linode? I think it's Linode. Anyway, not sure. So now my Linode server is provisioning, and once it's up, you can actually log into it. Username will be root. So anytime you log in, just remember your username is root, and your password is the password you created. Okay, cool. Now our server is running. Yay! Isn't this cool? Right now, so you can log into your server. You can use a command terminal and log in using SSH, or you could just use this Lish console here. Now, this Lish console, I don't know. I don't really like it. When you click on it, it opens this web browser, right? And it asks you to log in, right? So login is root, right? And your password is the password you created, right? And once you log in, you'll be in your server. It's just an empty server, so basically there's nothing in it. However, it's this thing, I don't really like it, not good enough for me. So we're gonna use Visual Studio to log in, and it's very easy, makes sense, makes our life so much easier than dealing with all of this at this point. I'm just going to close out of this. I could just X out of this, I guess. Yeah. Let us open Visual Studio. So we have our Linode server, right? Let's now open Visual Studio. Okay, here we are with Visual Studio. So if we go back to our instructions, we would see that now that it's booting, after Linode server started, you can launch it using Lish. We didn't like Lish, and you used your username root and the password that you created. Now log in with Visual Studio, which is what I want to do. So much easier. It reduces it just makes your life so much better, right? So first thing to do is when you're using Visual Studio, you need to install this remote development extension, right? I've already had it installed here, but if you wanted it, you can go to the extensions tab and then just type remote and look for remote development. You could also use Remote Explorer. I think that would work too, but I prefer that remote development. It installs a whole bunch of stuff, right? So it installs these 4 things, right? I already have it installed, right? So I don't have to install it again. So once you have that installed, you would have access to this button right here. It says open a remote window. So I'm going to click on this icon here, and basically it's going to ask me connect to a tunnel, connect to a host, connect current window to host. Now, if you use connect to host, it's going to connect quite all right. It's going to open a new window. Sometimes you keep track of these windows. So I'm just going to connect to a host in my current window. However, first we need to set up our connection, right? So let's start with that. First, it's going to tell you to pick SSH configuration that you want to use, right? Or you add a new SSH host. Now, this is a new server, right? This is one of the servers I have before that I've installed here, right? So this is a new server. I'm just going to use this one, right? Configure SSH host. And then for this, it just tells you what location your config file is located. I'm on a Mac. The first one's usually the one you should pick. Just pick where it's located when you create your SSH key, right? Remember when you generated your SSH key here, right? So usually it's located here. Here is the configuration. Now there are just 4 things you need to set. You need to create a name for your host, right? You need to set a host name. You need to set the user that you want to use to log in and where the SSH key file is located, right? So I'm just gonna copy this. Now this is here already for you, right? We're down here, right? So we clicked on that icon, we opened the Remote Explorer, we selected the current window, connect current window to host. We clicked on configure SSH host, and we're now gonna click the location where our SSH key is, right? And now we're here, and we need to set these items. And so I'm just gonna copy that, and I'm just gonna paste that right there. Usually this is tabbed. Okay, cool. Now I'm gonna name my server IoT Masterclass ML1. So let's just do that. The IoT Masterclass ML1. My IP address is, just make sure I have the right IP. Yep. So the IP address is this guy. So just gonna copy that. 143.42.0.52. Okay. Just paste that there. The user is always root. Remember when we logged in, we use root. And then the identity file is the location where the key you generated is, the SSH key. And that is the same. I'm using the same key here. All right. Just making sure I have this set up properly. Didn't see that earlier. Okay, now that we have this, make sure you save. I think I have everything saved. I save it automatically. And now I can X out of that. Now let's see if we can actually connect to this host, right? So I'm gonna click this button again down here. And now I will click connect host to window again. And now you can see in the list now I do have my IoT Masterclass ML1. I think that was the name. Yep. So I'm going to select that. It's going to say that I think like IoT Masterclass ML1 has a fingerprint of this. Do you want to continue? Are you sure? I'm very sure. So I'm going to continue. Now we're going to run in as root. We enter password for root user for that IP address. So I'm going to enter my password. And click enter. And if everything goes well, I should be connected. And I think I am. Yep, I am connected, right? So you see, I'm connected to this SSH, and that is cool. Now, let's go back to our instructions. Sorry about that. Now that I'm connected, let's open terminal. So you can see I'm on the root. ls, there's nothing in there. So very empty. So the next step say install the ML dependencies. So install pip for Python. I think Python 3 is already installed by default on these servers. If Python 3 is not installed, please install Python on your server if you maybe do it locally or on your computer. But on this Python 3 is already installed. Oh yeah, you see that? So we already have Python installed, Python 3.10.12. Right, so now the next thing we're gonna do, we're gonna install pip so that we can install libraries on our Python. So let's do apt update. Okay, so we've installed all the updates. Apt install pip. We want to continue. Yes. Escape that. Let's press escape for that, and I think it's good. So now pip is installed, right? So now let's go ahead and install the libraries that we need, right? So we'll start with installing Gecko. Pip install Gecko. So now let's install, we just installed Gecko. Now let's install matplotlib, right? Pip install matplotlib. Now we install pandas. Install pandas. Okay. Now let's install scikit-learn. Now you kind of have to install the scikit-learn that was used in the Colab, right? So in the Colab, the Google Colab, the scikit-learn that's there is the 1.2.2 version. Now you can check the version to confirm, right? But when I checked it, I think it was the 1.2.2 version. So we're just gonna go ahead and install that. If you install a higher version, if you just do pip install scikit-learn, you'll probably install the latest version, your model might not run, right? Because you kind of have to run it in a similar environment to what it was created with, right? If you use Colab for this, it's 1.2.2. It might update in the future, I don't know. But currently, as at the date of this recording, September 30th, 2023, it is 1.2.2, right? And so I install that. Now I'm gonna install joblib. Remember, we use joblib to export our model. So in order to import and use the model, to import and load the model, we would need joblib also, right? So let's go ahead and import joblib. Okay, so it looks like joblib 1.3.2 was already running there anyways. Okay, now to host our web application. Our web application is a Python web application and it uses Fast API. So we're gonna have to install Fast API dependencies. So it's just, if you can install the Fast API in the UVcorn, but we'll just do this. It'll install, it'll install both for us, right? So we copy, we paste that, and then pip install Fast API in square brackets all. Fast API gets installed. Okay, that was quick. Now I think we're almost there. Install our code dependency. We would need to install Faho MQTT, right? So let's install that. Okay, now we are done at this point. Okay, looks like everything's okay. Now it says download the repo, copy it to your root folder, and then run it using uvicorn main app reload. I thought there was a button here usually for download. I might be wrong. Maybe I just have to go in here and download it. And then I just go to the branch. Okay, I just need the zip file. So let's download that. Okay. Now that we've downloaded this, I can open the location, extract it, or just rename it. Its name is very long. We'll call it IoT MQTT Machine Learning. And then I can take this out. Okay, so now we have our server in this location, right? So we've downloaded the server. Now let's go to, all right, let's load our server. So in order to copy our server in here, I'm just gonna open, it's just easy to drag and drop things, you know. I like the easy way most of the time. I don't like complex stuff. So let's open the folder, right? So it's gonna ask you which folder you wanna open. I just want root, and okay. It's gonna ask me to put in my password again. Please enter and confirm. Enter password for root. Okay. And so that's my password. And now I'm connecting to the server again. I'm gonna trust this. Yes, I trust the authors. It's my server, I guess. And I'm connected to root. Yay! So I have root here in my Explorer. I'm just gonna cancel that. I don't need that. And I'm just gonna pull this guy and put it in my root folder, basically. So just copy it. Very easy. Copy folder. And IoT machine learning is right there. Now, a couple of things we want to do first, right? We downloaded our model, remember? Now, in the models folder, you need to replace the model files. So I'm just gonna delete this model that came with it. You can use it too, but probably old model. And again, if you wanted to change your model, you know. So I'm just gonna delete those permanently. Delete. And then I'm gonna copy my new model, Doug fan model.joblib, studio fan model.joblib. Everything goes into, yep, so it's in the models folder. Just make sure it's in the models folder. If it's not, just make sure you drag it all up and put it back there. So I'm gonna cancel this and I'm gonna go back to my source and v1 API server. And now I need to run this uvicorn main app reload. However, I can't just run it anywhere. I have to run it in the folder where the app is, right? So here we go. So I'm gonna open this and then I'm gonna cd into my server code. Cd space IoT machine learning. And then I'm just gonna run uvicorn main app -- reload. And if everything goes well, we should have our application server started, and the application should be on this server, right? It should be this proxy, right? So let me copy out the proxy. And now if I go to that proxy, I can load this. Yay! If you go to docs, we should see if it's loaded. Yeah, it's there. So you can see it's hosted, right? So we have the server on the Swagger showing. Let's try out a prediction and see what the result would be. So time of day, let's say it's about maybe 9 o'clock in the day, right? On Monday. 9 o'clock on Monday, there is motion in the room. Let's say the temperature is 65 degrees Fahrenheit, and it's the dog room, about a Monday at 9 o'clock. And now if we execute this, it says payload off. status success. So it says the fan is probably, so it's using our model, right? So you can see it right here. Things are changing. Now, if let's say it's on a Sunday, and let's say it's around 3 o'clock on Sunday, it's 15:00, and let's say the temperature is 73. So now let's try this out. Payload on. The temperature must be really hot, I guess. And it says you should probably put on the fan. So you can see that our server is pretty much set up, right? So there are a few other APIs here when we will talk about them also as we continue in the video. So here we have this API that allows us to set configuration on our device, just to add a temperature difference, to set the current day, because if you have a device, you can't go in, like if you don't build all those buttons, right? You can just send this to the device and the device configure itself, right? And then you can tell it to also execute a command and see what the result would be, right? So and here, so execute a command means to send a command to a device, right? And here we can execute a prediction for a particular gateway. So if a gateway wanted a prediction, you could use this to send it a prediction to a particular gateway. So you put the gateway ID and the parameters, and then once it makes the prediction, it will send the prediction to the gateway with that ID. So those are just the 4 stuff here. So the next thing we're going to do is install our event hub, right? So, and now there are some setup things that we need to do before we install our event hub. Make sure you put in your MQTT name in the API constant file. So if you go to the API constant file, we've gone through this in our previous classes, right? The IoT masterclass, the password, masterclass 1990, control topic, the telemetry topic, and then the server URL. That's our, right. So now let's continue. I'm gonna X out of that. And I'm just going to go back to the top here, go back to code with Francis. And again, I will put in the links directly to the code. You can see I'm not even logged in, so the code is available. You can download it anytime you want. All you have to do is just go to this link here, and you should have all the code from all the classes we've done so far, right? So I'm gonna download the event hub, very similar to the event hub we had the last time, right? So I'm gonna go to V1 MQTT publisher, and I'm gonna look at the installation requirements. Install source code editor like Visual Studio. We already have Visual Studio. Install npm and Node.js. On Linux, if we wanted to do that, we would use apt install. We already root, so we don't need sudo. So we would need apt install Node.js. Let me open a new apt install Node.js. That should install our Node.js. You want to continue? Of course, yes. And I just escaped that. Okay. Node.js has been installed. Now the next thing we need to install is npm. So now let's install npm, apt install npm. Yes, of course. Let me just X out of that, escape. Okay, so now we can just confirm that Node and npm are installed. Just make sure they're there. And so we have the version of Node and the version of npm. Okay, that's good. Now the next thing we do is to download this repository. So let's go to downloads, and then sometimes I forget where this is located. We go to branch. We want to download the v1 MQTT branch. So I just take the zip file for it. So let's open that. So that's the event hub code. Let's rename that. So I'll just name it event hub. And now what I'll just do is copy my event hub into the root folder, which I already have here, and just drop that there, copy folder, and now I have my events hub loaded. Okay, so now that we've copied our events hub, let's check if everything's working. So before this, let's just make sure we have everything in place. So let's go back here. So, okay, we're here. We've set the connection. First of all, we need to install npm, right? So let's install npm. Make sure our node modules are installed. npm install. Oh, sorry about that. I didn't log into the module. That's funny. cd event etab. Okay. Now we run npm install. Make sure we install all our required node modules, and then we run npm start. Cool. Now we can see that our event hub is working. Our node for event hub is working. Okay, so the next thing we're going to do is we're going to load our circuit. So take some time, build your circuit, or if you want to use the simulator, I will go ahead and load the simulator and we can use that for testing. So I will be right back. Thank you. So let's open our simulator quickly. So simulator, all the other projects we've worked on so far. Now there are two versions of this project. One has an LCD, which is this, and the other doesn't. So depending on which one you want to build, right? If you want to build the one without LCD, if you don't have an LCD and you don't want to bother yourself, you can build the one without the LCD. Fine, everything works fine. All you gotta do is make sure after you build it, you set the right access ID and the right password, and you set your correct device ID. However, I wanna use the one with the LCD. It just makes things a little bit easier, right? Because at least I can see what I'm working on, and I can actually plan for it, right? So now the other thing that I wanna do, I do have a circuit that I've already built, so let me open that up quickly, right? And then let's see. Set up my camera. Oh, okay, cool. So my camera is set up, and you can see the two fans. So the red is for the dog room, and I think the blue is for the studio. Right, so we have that here in our stuff here, right? So red is Parsons' room, which is the dog. Parsons is our dog, and the blue is the studio, which is my room, right? Let's go ahead and run our application. So we can run our event hub npm start. Our event hub is connected, so it says connected to topic IoT control, which is the control topic. And now let's run our API, UVcorn main app space dash reload, and that should run our API right there. So now let's run our circuit and see what happens. So I'm gonna start with this one down here, right? The simulator, and I'm gonna run the simulator. In the simulator, we're using LEDs to represent the fan, right? So you can see in the real one here, we have two fans. So let's wait for this to connect. It takes a while sometimes to connect. Let's just, oh, here we are. The Wi-Fi is connected. Now it's connecting to the MQTT broker. And let's hope the MQTT broker connects. Yep, the MQTT broker is connected. And you can see data is already coming into our event hub, and it's forwarding it to the API, and the API is making predictions if this should be on or off, right? So you can see when data is received, it sends it to this, which then forwards it to our API, and our API makes a decision if the fan should be on or off. And in order to test that, we could open up our API. All right, let's open up our API. Let's bring it up here. Our system says it's Monday, 8 o'clock. It reboots to a particular date and time. We don't have a clock in it, right? So now it says it's Monday, 8 o'clock. The dog fan, which is Parsons' fan, is off. and the studio fan, which is my fan, is off, right? The temperature, this is the Celsius, 68 degrees Fahrenheit. That's for the dog. Room temperature is 68 Fahrenheit. For the studio temperature, it's 70 degrees Fahrenheit, right? So let's go ahead and reduce the dog room temperature. Let's maybe reduce it to 14. Let's see what that does, right? We send the data. The data came back and it says the value is off. Remember we tried that API, right? It's still telling us the value is off. Even with that temperature changed, the value is off. So it's calling the predict API, right? It's actually calling this execute predict, right? So basically it's telling us that the value is off. So what do we want to do now? If you noticed our model, it was very good at predicting when things are off. It wasn't so good at predicting when things are on, right? So let's use an easy one, an easy use case. Let's do it on a Saturday. Let's set our clock to a Saturday. So I'm going to set our clock to a Saturday. So I'm going to go to the set clock gateway ID. The ID for this is WOKWI001, right? WI001. Okay, let's still keep 8 o'clock on Sunday. Let's still keep that. And let's send that now. Once that is executed, we can see we got a 200 acknowledgement, and we see our day in our clock has changed to Sunday. However, even though our day is Sunday, the ML APIs is still telling us that it's still off, right? So it's like, yeah, I know it's Sunday, but it's in the morning, temperature seems good, fair enough, you should be off, right? So let's do something different. Let's say we change the time, right? So let's change the time to 3 o'clock on Sunday, right? And now we execute. We have 8 o'clock. Once the data comes in, it says it's 3 o'clock. It sends the data to the cloud, and the cloud sends back and says, hey, yeah, it's 3 o'clock. Your temperature is pretty high. It's 70 degrees Fahrenheit. You need to be on, right? And so the studio room fan comes on. Here it's an LED, right? So that comes on. All right. So again, like, why is this not coming on? It's very cool in Parsons' room, so he doesn't need the fan, right? It's Sunday, and the ML figured out that, okay, it's 3 o'clock, the sun is up, it's hot outside, it's in the daytime, but the studio is very hot at 70 degrees Fahrenheit, but the Parsons' room is at 58 degrees Fahrenheit. That's pretty low. So let's increase Parsons' temperature by a little bit. Let's take it up. That's 24.2 degrees Celsius, which is approximately 76 degrees Fahrenheit. Now, once we increase that, it sends that to our API. Our API says, hey, Parsons' room is very hot. We need to reduce the temperature. So it puts on the fan, which is the red LED in this case, right? So you can see blue LED is on, red LED is on, which means both fans are on in both rooms, right? Again, let's assume we reduce the studio room temperature to 16 degrees Celsius. 16 degrees Celsius is about 62 degrees Fahrenheit. So you can see it's already sent the data to the ML model API, and it turned that off. Same thing with this guy. If we were to turn it off, reduce that, that's about 68 degrees Fahrenheit. Will it come off? Yeah, it's cool enough. You can manage Parsons. So we have that off. So you can see, again, we could change our time to something else, right? Let's change our day here to Tuesday. And you can add some difference to, and you see why we need that, especially here, because I can't just change the temperature in my room, right? So we'll talk about that later. So let's still do like maybe 16 on Tuesday. All right, and then let's execute this. And now we got a success, a 200 success. So it's Tuesday, 16 He says, well, I got the data, everything is okay, everything should be off, right? Now let's do the studio room. Now let's increase that to 30 degrees Celsius, so let's say 26 degrees Celsius, which is about 80 degrees Fahrenheit. All right, it still says there's no need. It's really good at predicting when it's off, and around that time anyways, I'm probably at work, right? So it still says it's off. Now let's change our day to Saturday. So let's assume it's a Saturday when I'm in, and we execute, same time, same everything, right? And now we send and say, okay, our current day is Saturday. What should happen, right? And now once it sends that command up to the API probably will come back and say, hey, the studio light should probably be on. Yeah, and the studio came on, right? So the studio light came on. And if we do the same here on Saturday, and we increase that temperature to 28 degrees Celsius, which is about 83 degrees Fahrenheit on Saturday, now processor's room's fan should probably come on. Well, the more data you put into the model, the more it will be able to understand more. But if we had maybe more data, the ML model will probably be better, right? Here we have a real device, right? This is I think the ID for this in the code is walkway002. So I'm just gonna go ahead and turn this on, right? So let's turn this on and see what happens. So give me a second to turn this on and set things up, and I will be right back. Thank you. Okay, now I'm back. So here we have our system, right? We have the red fan for Parsonson's room, that's the dog's room, and the blue fan, that's for my room, right? Same with the temperature sensors, although these are both temperature and humidity sensors, but we're just measuring the temperatures for now. Here's some MOSFETs to drive the fans using a PWM control. And we also have the motion sensors for both rooms right there. So, and we also have the LCD screen. So let's go ahead and start this up. UVcorn main app reload. Right, so there we go. Our application is started, and I will also be starting up the event hub, which is in PM start. That should do the trick. Okay, so both our backend and our event hub started and connected. Now let me go ahead and start the ESP32 and put it on the device. Okay, so now both fans are on while it tries to get connected, and here we go. Now we're connected. So you can see from the screen here, it's Monday, 8 a.m. in the device. The dog fan is off, and the SFN, that's the studio fan, is off also. The temperature in the dog room, dog TP, is 74 degrees Fahrenheit, and the temperature in the studio STP is 73 degrees Fahrenheit. I'm just gonna go ahead and reload the backend just to make sure everything is okay. And we can see some data is coming in, right, from our walkway002, which is our device. I'm just gonna copy that ID. So let's change the day, and we're gonna make it Sunday, and let's just make it around 2 o'clock on Sunday. We can keep the temperatures the same. And when we run that, now the data has come in. You see that changed to Sunday, 2 o'clock. So at this point, it sends data back to our server, and our server responds if the fan should come on. And you can see it made the decision that at 2 o'clock on Sunday, both fans should come on. Now, maybe we want to reduce the temperature. So this is 75, right, for the dog room. Let's say we reduce that by 12. We reduce that by 12 degrees Fahrenheit. And so now the temperature has reduced to 63. Let's see if it will still be on, even though the temperature has gone down. So it looks like the dog room fan has gone off, right? and the studio room fan is still on. If we decide to say, okay, we want to change the day, maybe Wednesday, and then the time to, let's say, 1 o'clock on Wednesday, we might get something totally different. Now, this wasn't set. I didn't preset anything. The machine learning algorithm is just making decisions on what the state of the target, which is the fan, should be based on the data that we supplied to it. So the ML model has made a decision that at 1 o'clock in the afternoon, right, on Wednesday, at these temperatures, both fans should be off. So again, I hope you enjoyed this video. It's been definitely a lot of episodes to get to this point. If you enjoyed this, please feel free to like, comment, share these videos, and I will see you in the next one. Please don't forget to add your questions to the comments also. Thank you.